I know that you have lots of talk about. I would like to start on time this presentation. I would like to cover lots of information. It will be very brief, and I would like to, if during the presentation you will stop me anytime, because it's not about what I wanted to tell you, show you about informations, but I would like to answer your questions, your needs. Okay, let's start with the word of prayer. Let's stand up, please. Dear Heavenly Father, we are so grateful for blessing morning. Thank you for all those messages we heard. We heard about you, about your love, about your assurance that you are next to us, that you are helping us in many ways. Thank you for your mercy, for your plan of salvation. Thank you that we are having also those technical presentation, that we know what to plant and how to plant, that you also teach us who you are and what is your character in characters of soil or characters of plants, how they do it. Please be with us and bless also this moment. Amen. Okay, so at the beginning I would like to say a very important thing. This presentation is basically second part. So maybe you're wondering, what about the first one? The first one is already online. You can find it on our YouTube channel. It was presented last year in TGM conference in Austria. And I will briefly say what it was about, and then I will continue with the part 2. So it's all about improving soil health. I will say a little bit about the concept, God's concept, or how it works in nature, that plants are flourishing. They have own immunity. They are capable to have such an immune system that they can carry lots of disease, and also are resistant to many pests. I could say also all pests. We will say, and the main topic about today will be how mineralization and how minerals in the soil could help to prevent against some disease. So we will say about importance of the mineral, many of those, what are the deficiency symptoms, and what are the excessive symptoms, because the best have to have a good balance. And then I'll tell you some information about soil test. So again, anytime you can stop me and ask question. Okay, it's not about information; it's about what you'd like to know. So, what is the God concept of health? We knew it from human health. We know the program New Start. You are very familiar with this, and technically it's exactly the same what the plant needs to have. They need nutrition, they need exercise, although they don't move, but they have some exercise. They need water. You know that plants need water. They need sunshine, not too much sunshine, but not too little sunshine, like optimal. They need also temperance, related that if somebody is, they need to have it in a balanced form. If something is overloaded, it just hurts plant the same way as some overdoses of something can hurt also us. Even good things, of course. Air, of course, they need air. They need rest, and we know about the physiology of plant, how they have a rest during the night or even during the day. But we will not talk about it today. And of course, the trust. Without God, like no life will be possible. He set up all together. He put all those minerals, create body for plants, and he initiated somehow. He put some spirit, some life into it, so it just move it by itself, like a train when you push it and it goes by itself. Okay, so the main triangle I would like to explain is that plant needs not only sunshine and water, but also plant is dependable, very dependable on biology that is underground in the rhizosphere, which means in an area of roots. But only those you need also some microbes, some fungi that are covered above the ground, on the top of the plant. The same as symbiosis works in our guts, that we are, for example, I have 75 kilograms, but I know that 3 kilograms of mine is not mine. Those are any microbes and bacteria that works in my body in order to process some food and digest something that is really valuable, flourishing for my body. So the same is for plants. They need biology. Basically, they are very dependent on biology. Again, when you have a soil, and yeah, this is the good concept. Once you have a soil, it is well known that usually, it's not 100% case, but usually soil contain all required minerals for the plant, all of them, almost all of them. Let's say we say all of them, and in some cases, not typical cases, maybe some minerals are missing. But those are rare case. The only problem is that those minerals are present in the soil, in the rock, but they are not available for a plant. So there are some minerals that are available for the plant, but there are some minerals, the same minerals, is not available for a plant. Biology is the thing that kind of creates condition that because they want to live, they have some enzymatic processes, they do some recycling of minerals in the soil, and they kind of make it available for the plant. So you can even have it available from biology process, or you can add it from outside. You know, we have lots of solutions that could be used in order to replenish minerals in the soil, in order to get they are available for the plant. And but once you don't have those available minerals, even biology is thriving or something else, or is missing at all, and you don't have it, even plants are struggling. So God creates something very flourishing. We have sunshine, we have this photosynthesis, and they create lots of sugars in the plant, and this is a building materials for the plant. But there are lots of other sugars and saccharides that goes through the roots and outside to the root zone that feeds those microbes. They create environment, they bring some minerals that are needed for the plant, and the plant is utilize them, and it's growing and it's fine. And if some link is missing, then it needs to be done some intervention. You can even, I don't know, create some artificial light. It's usually done in greenhouses, because most of the greenhouses stop certain wavelength of the light, which is needed for flourishing some processes in plants. Of course, you need to water. If you have a lack of biology, you need to do some techniques how to enhance it. And if you have missing some minerals, also you need to do some intervention in order to add them, because when you don't have a good photosynthesis, and this is based on the minerals that is needed for the plant, you cannot go through the circle. So we are managers. We are the one who are trying to coincide with the God's plan for the plants, how they can grow and be happy, flourish. But we need to know what are the steps that are missing. So what I would like to work right now with you is about mineral balances, or minerals that are needed in order to plant to be healthy and grow. I took lots of information from this book. It's called Intelligent Gardener, Growing Nutrient-Dense Food, from Steve Salomon. I found this book as a good recommendation from Adventist Agricultural Conferences that was done in United States. I bought this book, I studied, I find some valuable information how to do tests and how to add to the soil something that is missing, and again remove or not to add something that is accessible in very huge access. So of course there are some amendments that you can use in order to put them into the ground. If you wanted to do it commercial way, you can go to the garden shop and find whatever you need in fertilizers, or there is some kind of a list of allowable components or minerals that you can use in organic agriculture or bio-organic agriculture. So this list contains the chemicals or minerals that are not, they have no side effects for biology, for example, in the soil, or some other side effects. Okay, so there is a Omri products list. It's used in Canada, and USA, and Mexico. In every country in Europe, there is some kind of association, or you can find this list in every country. Basically, European Union has some common ground recently that they have a list of those allowable amendments to the soil for organic gardening. Okay, so your task is to find what is valid in your country and use it. Is it possible to do something with light? No, no, it's not possible. Okay, let's do it this way. Let's do it this way. I will, if you are interested about this presentation, I'm free to share it, no problem. Just come up front after the presentation and give me your email. I can send it to you. Okay, let's do it this way. Okay, so let's go to description of minerals. But before I start, I have to tell you that there is a certain ideal soil mineral balance, and it's based on the capacity of the soil. You know that sandy soil has a lower amount of minerals, and heavy clay soil has a much more capacity to carry minerals that are available for the plant. But in percentage, it's well-known fact that, for example, you need to have at least, you have to have, for example, from capacity, 70% of capacity of those sites that are available for minerals. It needs to be carried by calcium, for example. 12 to 18% needs to be magnesium. Potassium is maybe 3 to 5%. You don't need to know those numbers. They usually, I will show you later the table. Or check the presentation from the last year. Those are much more in details explained, okay? So there is some kind of balance of minerals, and it is good for a plant to have this balance. Basically, it's good for any plant to have this balance of minerals. Once you have it, some excesses, this excess is kind of blocked availability of other minerals to the plant. If you have a lack of those minerals, of course, plant cannot get what needs. So there is a balance. So once you will do a test, and we'll talk about tests at the end of the presentation, you can just find out what is lacking. You can find the source, and you can rebuild the lack using those amendments. The whole idea is about starting this machine, starting good photosynthesis based on good minerals, starting good biology that replenish the mineral balance, and it will go by itself. So there is some kind of intervention tools that can help you to start this process in order to plants that grows in a better place. Okay, I did something like okay. Let's go to the minerals. So the first one is very important, is calcium. Yesterday we had a networking session, and one lady was discussing that she had a very bad problem last year with tomato and some disease on it. Calcium is a very important element because it contains all those 70% of capacity, roughly. It's a building cell wall structure component. It's responsible for cell separations. Basically, if you would like to have a big yield, you need to have lots of calcium available for the plant. Yeah, there are some other options. It builds soil structure, which means it makes soil fluffy, like light, if you have a right amount of calcium. And what is important is that calcium is not mobile in the plant, so it is immobile. You need to have some other elements that could carry calcium into the plant, but it doesn't move in a plant anymore. On the other side, it's very movable in the ground, which is good also. Okay, so when you have a deficiency of calcium, you can observe some of the drawbacks. For example, main bud of the plant could very easily get dry and die by itself. You can observe also when young leaves bend into C-shape or, for example, root tips get rot. For example, in tomato, this is typical. When the end of the tomato just get rot, kind of black one. Or when in apples, it's also typical when there is a lack of calcium, they create some kind of dots. Maybe you saw it in apple. They call it cork spot or bitter pit in apples. This is not only a deficiency of calcium, but it also could happen. We said that it's immobile. Calcium is immobile in a plant, but it could also be a reason for a lack of water. When it's drought, sometimes this is what happens, because the calcium just cannot get to the plant. Also, if you have a lack of boron, boron is like a carrier for calcium to get to the plant. And if somebody has some problems like dying or it's a problem with apples or tomato, and even lady from yesterday, I mentioned that she used some kind of calcium boron application, and this helped solve the problem. Okay, usually the allowable range of having calcium in the capacity of the soil runs between 69% up to 70, 75, I heard it, but even 98%. So this mineral is kind of has a big range of having it in the soil without affecting excess of other minerals. But if you have lots of calcium, it binds other nutrients, and especially it is responsible for lower intake of magnesium and potassium and some other microminerals. So once you have a lot of calcium in the soil, you can observe deficiency of those two or other minerals, magnesium and potassium microminerals. Okay, if you lack calcium, there are several ways how to add it to the soil. There is a calcium carbonate. It contains 38% calcium and very low amount of magnesium. It's a lime, basically, a low magnesium lime. If you have a dolomitic lime, you have to count with this that it contains also, together with calcium, it contains some magnesium. Why I'm talking about it is, the reason is that usually when people have a low pH and they wanted to add increase pH, they add lime. But they have to think about it that sometimes they don't need to add calcium only, or they have an excess amount of magnesium, and when they use dolomite lime and they will use it in a regular way, they can very easily increase magnesium level in the soil. So yeah, there is a question, please, or no? Usually lime contains also magnesium, but there is a calcium carbonate or lime with low amount of magnesium, and there is a dolomitic lime that contains 10 to 12% of magnesium. So when you need magnesium, use dolomitic lime. And when you need calcium and magnesium together, add dolomitic lime. But when you need only calcium, use the low magnesium lime. That's the message. Yeah. Okay. I will refer you to the first presentation. pH, it's kind of when you get the balance, the pH just set itself to the level maybe to 8.5, 6.5 to 6.8 pH. So you don't need to think about pH, you have to think about mineral balance. Yeah. Because sometimes you have lots of, in the soil you can have lots of main cations, which is potassium, magnesium, and you have a lack of calcium. But your pH looks like fine. But because of those excesses of those other cations, those creates the higher pH or normal pH. So yeah, it's about balance, it's not about pH. That's what I'm thinking. It depends on what other cations are, how other cations are presented in the soil. Yeah, we'll talk about it. So there are some other sources, mainly used in organic gardening. It's phosphate, soft phosphate rock. Gypsum is also a good source. It contains not only calcium but sulfur as well, which is mostly lack in the soils, at least what I tested in Slovakia, many soils. And some industrial byproducts, for example, when you process sugar beet or you have some waste from this, it contains lots of calcium. You can use it also. Wood ash also contains calcium, together with other minerals, of course. Magnesium, it's the second main important cation in the soil. It's a part of chlorophyll molecules. It's very essential. It's essential for photosynthesis. If you have a lack of magnesium, phosphor is processed in a plant in a poor way. So it's very important for processing phosphor. Activates several enzymatic processes, breeding, fragmentation, and so on. So it's very essential, good and essential mineral in the soil. It affects very much soil structure in such a way that more magnesium you have, the more stickier are the soil plates, and it looks like you have heavier and heavier soil. For example, when you have rain, and after the rain, on the top of the surface, it creates some kind of a layer, crust. Yeah. So this is first sign that probably you have lots of magnesium in the soil. It helps in production of reproductive organs, of course, and it's very mobile. And this is very well known when you have deficiencies. In tomatoes, for example, you have a lack of magnesium. Usually plant took from the bottom leaves, older leaves, this magnesium and move them to the higher places where the reproductive organs are made at that time. So yeah, it's movable in the plant. This is also a reason how to distinguish that you have lack of magnesium. So once you have a deficiency, it is very visible on those bottom leaves of the plant. It's yellow, all the bottom leaves are yellow. And you have a light green between veins. Those yellowing is between veins on the leaves. Or sometimes you have some stains. So once you have which I'll show you. For example, this one, yeah? There is a vein, and between veins you have the light green spot. In tomato you can also see some between veins, the whiter parts, you see? And it's all over the leaves, it's not on the edges. Edges is something different. So also, low magnesium, adequate magnesium. You see those spots, yellow between veins. That's the sign of lacking of magnesium. Also, when you have a deficiency, the growth of the plant is very slow, and the flowering happens very late. If you have excess of magnesium, it causes deficiency of other cations, calcium or potassium or iron, for example. So again, you have similar symptoms of those deficiencies, and as I said, it negatively affects soil structure. Do I have some slide about it? Yeah, I will talk about it more. So those are the sources of dolomitic lime. Sorry for Slovakian pictures, but it was presented once in Slovakia. We could find this. So you can have this dolomitic lime, thinking about there is a calcium and 10 to 12% of magnesium. And somebody is also using Epsom salt. I think that Epsom salt is not allowable in organic gardening, as far as I know. But yeah, it's a magnesium sulfate. It contains sulfur and magnesium too. If you have a, let's talk about calcium and magnesium flocculation. This is an image. I don't know if you can see it. This is a microscopic image of the soil particle of the clay. So let's say this size is maybe this size is maybe 5 micrometers. From here to here, it's 5 micrometers. Very small number. 5 micrometers. It's even less than the lumen of the wood cell. I'm a wood scientist. Oh, I didn't say anything about myself when I started the presentation. Okay, so at the end. 5 micrometers is a very small number, and I think that hair is maybe 100 micrometers thick, so this is only 5. And the clay is contained, or consists of plates. They are layered on top of each other. So once you have a calcium is usually enter inside those plates and open them. So once you do it in a bulk, you can see that soil is some kind of fluffy, soft. Once you have a magnesium, lots of magnesium in it, magnesium has a tendency to stick those plates together, which means it binds them, the soil has lack of drainage, water just stay on the top, the surface, it doesn't sink inside. So it decreases pore spaces. Soil is hard, very hard, impermeable. So this is important for having balance of those minerals. When we talk about potassium, it's very strong, important for strong stem and stalk. Utilize water if you have a sufficient amount, regulates evaporation of water and gas exchange at the boundary of leaves, improves durability in the winter, especially for plants that are very sensitive to frost, and it's mobile in a plant, the same way as magnesium, also potassium is mobile in a plant, which is used for searching of deficiency. So when you have a deficiency of potassium, the leaves turns to burn out or dry. It gets brown and then they get yellow, brown, and then they just burn. They start to be dry. And this happens especially on the top of the tips, like here, or on the edges of the leaves. That's a typical calcium deficiency symptom. Or potassium symptoms, sorry. It also, I have saying that I told my wife many times, don't listen what I say, but listen what I think. So when I'm talking about potassium, I'm talking about potassium, no matter what I say. Okay, so you have those edges that gets yellow, brown, and then they just dry, or tips of the leaves. Sometimes they can create also some spots, like I don't see it here. This is not only edge, but it could be some spot, you know, like some small brown spots on the edges. If you have excess, again, this affects the deficiency of other cations, calcium, magnesium. Yes? Kalium? Kalium is calcium, yeah. Okay. Those are the sources of potassium. Common is potassium sulfate. I'm not sure if this is allowable in organic gardening. Potassium nitrate, but only in this configuration. I found out, or I read, or maybe listened to some presentation of gardeners who use those, and they explained that some of them are not a good one because of adding some other additional materials into the substance. So, and you never know what is put into the fertilizers. Manure is also a good source of potassium, granite dust, seaweed, very common in organic gardening. Seaweed contains 5 to 16% of K2O. Wood ash is also used as a source of potassium. Of course, you need to be careful with wood ash because it contains calcium and also magnesium. Okay. Let's go to another cation. It's the fourth one of those two main cations. It's a sodium. Very important when you want to plant beets, spinach, mangold family, and barley. If you lack those, if you lack this mineral, they're just starving. It helps in chlorophyll synthesis, optimize conductivity in soil, which is also important for exchange of minerals at the root boundary. If you have a deficiency in sodium, the growth is weak and yield is small, and you have but only in those plants that require sodium. If you have excess, which is common in a region where there are lack of rain, or there is a huge drought, longer drought for many years, so increase of sodium is very dangerous for soil. But there are some soils, usually soil should contain optimally 1 to 2%, roughly 1 to 2% of capacity of sodium. But those sodic soils that are in the Middle East, for example, or some other part of world, they also contain 10 to 12%. That they have to have a special management of the soil in order to get growing some crops. But yeah, it's possible. But optimum is 1 to 2%, no more than 3. If you have excess, it usually makes replacement for calcium or for potassium, and this is resulting in bursting tissue after rain because it just pops out the molecules of the leaves. How to remove them? This is a problem of greenhouses. In greenhouses, you have a high level of sodium because of the irrigation. So the way how to remove sodium from the soil is just flush it away. Use heavy watering, and just this goes this just run off through the water on just sink inside to a deeper level of the soil. Sources: sea salt is probably the best one because it contains lots of others microminerals. I'm not sure if it is available. You can find some available in the store. They use it for bath, for pools, for example. But those are kind of refined. This is a refined salt. I'm not sure if they have unrefined in Europe. Especially, I tried to look for those, but we are in a country, we have no sea, so it is difficult. But yeah, maybe it's better to eat. Seaweed is also a good source of sodium. Yeah, there's a question. I don't know what is it. First time I heard about it.
It's very rich in magnesium, the Celtic salt.
Celtic salt. Okay.
Yeah, it's sea salt. It comes from, if I'm not mistaken, generally comes from a specific region in France.
I wouldn't. Yeah. If it is salt, it probably consists of NaCl. That's literally probably majority of the salt, maybe 95, 98%, and the rest of the percent will be maybe magnesium and some other microminerals. So, yeah, it's a salt, it's a good one. You need to know how much you are lacking and how much you can afford to put it on your garden. For example, I have like 0.5% from my capacity in my garden, and I plant like 400 square meters. And for 1 year, I use usually 0.5 kilograms of salt, sea salt, that I found. Yeah, it's very easily to apply it. Yes?
Do you dissolve the salt in water?
Yeah, I dissolve it in water and you spray it evenly. Or you can just, it's hard to put it 0.5 kilo on 400 square meters. Yeah, the question? This I don't remember. Technically, I'm not sure about it. I have to take my table. I don't remember all those numbers. I have tables. I go according to those. But you should have enough. You should have enough water in order to cover this land. And then it doesn't matter on concentration, you know, because if you have very high concentrate, but you need to run through the field in order to spread it all around. So use as much water as you need.
10 liters for 1
It will be much, maybe more. It will be more. I usually use 40 liters for my garden, which means 40 liters, half a kilo. So let's say 50 liters for half a kilo. Should be enough. Yeah. Okay. There are some. Those are the main cations, and there are some. I usually do it before the season or in the fall. As fall is especially good for calcium amendments to add in the fall, autumn. Yeah.
So not when you have the crops on it.
No. You can use also those. There are some fertilization that you can use as a foliar application, but they will not supplement need of the soil, because those are like very small concentration. Foliar application will help you to fix the problem in a plant, yeah, but not in the soil. Those are like, yeah. So I usually do it in the fall or in the springtime. Actually, once you run this system, it takes like 3 to 4 years to get the balance, and then you just take care of boron and some microminerals I don't know, cobalt is missing in my soil, for example, and I use like maybe half a teaspoon a year, maybe even less. This is a very small amount, because you cannot add, there's some limitation of adding minerals to the soil every year. Okay, so let's go to anions, not onions, but anions. Anions. Anions? Okay, anions. Okay, cations, anions. I start with nitrogen, although nitrogen has two forms. One is cation form, and the second one is anion forms, like ammonium, the plus, and nitrate is minus. Both of them are soluble in water. The second one is leachable, very leachable, and the first one stick on a colloidal. So in order not to leach, colloidal means in this soil structure, in order not to leach. Yeah. There is some special nitrogen cycle. So usually farmers use nitrogen, or conventional farmers use nitrogen all the time. But it's funny thing is that there are lots of nitrogen in the nature, lots of them, especially in the air. I don't know how much, 70%, 70 something percent of nitrogen is what we breathe. Of course, plant cannot take this nitrogen for itself, and there are some special processes in the soil through biology that the plant can get to that nitrogen. It's very important for production of chlorophyll, growing of stems, leaves, reproduction, growth. If you have a very nice, greeny, heavy green plants, then you know that you have plenty of nitrogen. Sometimes too much also can hurt, of course, a plant. Plants that have lots of nitrogen are very susceptible, very easily attacked by some of sucking insects because of low structure sugars they contain in a plant sap. So it's, as I said, it's more abundant element, but in the organic gardening is some kind of challenge. Yeah, there's a question at the end. Yes. You just implement it even between rows, and roots just took it from the sides, or just spread it on the top and water them in order to get inside. Yeah. This is not valid for amendments that are not soluble in water. I'm just thinking about which one of those are. Well, I don't know. have to think about it. But yeah, you just spread it between rows. It's the most easier way to do it. And just wait for the water or some microbiology that it spread all around. When I start with this system, I use copper in order to place them into my garden. And I just mix all these amendments into one bucket, mix it, and spread it. And I was not sure if I don't know, it was maybe 100 grams of copper was in a huge bucket, 10 kilograms of bucket. I was not sure if this copper gets to every place in the garden when I spread it. Because, you know, you have different sizes of elements, particles, you mix it, the smallest one get to the bottom and so on. But on the other hand, when next year I did analysis, copper was everywhere. Like I had exactly what I added. So I'm just thinking that there are some bioprocesses, high-fast from fungi goes and took it wherever it is and bring it to the place where it's needed. Okay. As I said, this is a challenging organic garden, but there are some sources you can use it. When you have a deficiency, slow growth, small crops, few fruits, light green leaves, and late green leaves, sometimes they drop often. You have thin stem of potatoes, for example, very thin one. When you have excess, there is a rapid growth. You have those dark green, almost bluish color. Plants often lay down because of the structure is not sufficient. Plant gets very easily attacked, as I mentioned, and you have too much nitrates inside the sap of the plant, which is not good for the health of the plant. And once you have lots of nitrogen in the plant, it's very hard to store them for a longer time, so they get rot very easily. It's typical when you have a cucumber from common conventional store, you just place it on a table or window, and after 2 weeks it's rotten. But once you have a good mineralized soil, it can last for a month. I heard a story about apple that wins some competition because it was very nice, shiny. It was planted on those ideal mineralized soil. And next year, the owner of this apple came to the same competition and win again with the same apple. so, yep. Okay. Nitrogen sources. Urea is not used in organic gardening, but this is the safest conventional source of nitrogen. It prevents evaporation, and then you have some other nitrates, ammonium, calcium, ammonium sulfate, and so on. In organic garden, we usually use even compost or manure as a source of nitrogen. Or I usually use, because in my place I couldn't get to the good manure, so I try to find some other solution, and I start to use those protein meals. This is kind of good source of nitrogen, including some other minerals, of course. And these protein meals, it means that it's made of some proteins. For example, soybeans, that is used for feeding animals, rapeseed, flour, alfalfa meals, also good source. I can find in my store alfalfa pellets, and I use them. Even this year we use them for planting or for transplanting tomatoes. And during the season I add another application of those alfalfa pellets. Very easily, just make a row, place them inside, cover with the soil or a little bit of compost, good compost, and the biology just take care of itself. So protein meals is really good source, and there are some also natural processes that fix nitrogen. You probably know about legumes or legume family, how they cooperate with microbes that live in the roots, and they create some kind of nodules, and they are full of nitrogen. And when the seed is made in a plant, they took this nitrogen and place it into the seed, into the legume or peas or beans, inside. That's why we eat legumes, and those are very good source of proteins for us, because nitrogen is base for the protein as in the molecules. Okay, and there are some other even symbiotic bacteria within this process, or there are some other non-symbiotic bacteria. There are free living bacteria. They can also provide some type of source of nitrogen within the soil. Of course, you need to then take care of the soil. You need to do some processes that doesn't harm biology in the soil, which is not sometimes in conventional gardening possible. Okay, another very important element is sulfur. Important because of, I did maybe 30 test analysis of different soils all around the Slovakia, and I found out that sulfur is missing almost in every sample. Yeah. Yeah, go ahead. Yeah, go ask. Yes, that's true. Yeah. Yes, that's true. Yeah, yeah, we live in a, yeah, we live in a, yeah, you can have an even choice to find organic farmer that doesn't use those compounds, which is kind of very hard recent days because there are not so many organic farmers. Jirka, how you do it? Ako zháňaš kompost alebo hnoj, keď, či z akých zdrojov máš ten kompost? Že či nie je problém s antibiotikami, čo sa dávajú zvieratám na rozkladanie? Takže kravské sú horšie, hej? Okay, yeah, there is a problem. Mainly, most of the time, it's a problem of cow manure. When you use horse manure, it's not very problematic. But yeah, you need to know the source. Actually, when you take a look at the table, what the manure is composed of, how much nitrogen, phosphor, calcium, potassium, potassium and magnesium, you find out that if you have a manure, cured, how they call it, ready manure, like it's processed manure, when you leave it on sites maybe for 1-2 years and it's just processed, rotted manure. When you have a rotted manure, the composition of rotted manure is exactly the same in percentage of those main components as rotted compost from plants. So basically, it doesn't matter what kind of you use, but in plants you have an assurance that they are in good sources. You could have a bigger assurance that you have a good source. Yeah. Question at the end.
With the potted manure, is there like a, say the manure is like 3 years old? Would it be the case that after that time any antibiotics or something kind of?
Yeah, I think most of them are gone. But there are some very firm antibiotics that they stay for a longer time. I don't know. I'm not a biologist, so I cannot say that for sure. But yes, most of them are gone. Mm-hmm. Okay, so they remain. Some of them remain. Yeah.
This is what I wanted to ask.
Yeah. Question is. Yes, especially, yeah. It is sometimes good thing or bad thing because, for example, from feather meal is good. Sometimes when you lack of copper in soil, it's good to take it feather meal from the poultry production because they feed those poultry with copper in order to not lose the feather because they have some problem with feathers if they have a lack of copper. So and this copper goes to the feather, and this copper you can like use it in your garden. But again, it all depends on what kind of chemicals do they use and how they affect and process and get to your garden. So it really if they use antibiotics, I will be probably cautious about it. Copper is fine because it's processed. It went through the guts, it went through the process of the animal, and it's similar like it happens in the biology in the soil. Yeah, it goes through the biological process and it's available for plant. But with others, yeah, you need to know what you are buying or how they do the processes within this farm in order to be safe. So it's not, I don't have just answer yes or no. You need to check the source and what if this source is not affected your biology in the soil. Cover crops is also a good source of nitrogen. I use it because I have lack of manure, and I use it for several years. Once the seasons stop, I plant cover crops, mostly legume cover crops, or rather mixed right now. Not only one legume, but mix of legumes and mix of grains and legumes all together. It's a good source. For example, alfalfa plant can give you almost 200 kilograms of nitrogen per hectare, and for very demanding crops you need maybe something like 300 for cucumbers, for example, or tomatoes, or some other plants, squash, for example. So yeah, there are some manure, green cover that can bring you lots of nitrogen in the soil. You need to just process them. You need to have you need to cover the soil all the year round. So you will not just plow in the fall and leave it open all winter long, because even the plowing needs to be done at very low temperature, so the nitrogen which is available in the soil doesn't evaporate easily out. Or when you plow it, you just replenish it with some other green manure or cover crop. But yeah, it's a very good source. I use it. You have to count it. Sometimes it's not sufficient for certain crops, but then you can add some protein meals in order to fix the problem for more demanding nitrogen plants. Okay. Yeah, another question. I heard about it. I haven't tried. I tried last year, but my purple clover didn't get well, because I wanted to plant purple clover at the bottom and after that place tomato transplants into that field. But yeah, I was not successful to establish good purple clover. Yeah. So yeah, I think it's possible, but it needs to be, I don't know, try and error. Yeah, maybe there are some books, maybe they do something, some industries, or maybe some institution do some experiments about it. Yeah. Raw cover. Yeah, it needs to be small. Yeah, that doesn't go. Or if you plant higher crops like tomato, you can even have a higher. But then you need to make a space in order to get up when you grow those tomatoes. Okay, I can go on and on because we have a sulfur, deficiency, small plants, cabbage family requires that. For example, if you have excess, it lacks some other, breaks some other minerals to intake of other minerals to the plant. Sources, elemental sulfur, gypsum is very good source if you also lack calcium, and on and on. Phosphor is one of the good elements, important elements, sources, and there are some micro elements, very important. I will at least stop at the boron and I will finish because we can be here for another hour, okay? So, boron is important. The reason why I'm talking about boron and sulfur before, yeah, I have to mention that, they are leachable, very easy leachable in the soil. Once you don't have enough organic matter in the soil, then you need to kind of add them year by year until you reach some level of organic matter that it will sufficiently hold this boron in the ground, and you can use it all the time then. Boron is important for, as I said, for calcium mobility, and it leaches. If you have a deficiency, it happens in my field, that's why I'm talking about. If you have a deficiency and you plant roots, how they call it, beets. When you plant beets, the sometimes you have a black hollow inside, and that's a sign of deficiency of boron. Some deficiencies also in cauliflowers. You see, it creates some holes inside. I saw it even in my potato, big holes inside. And so this is deficiency of boron. It's very easily to replenish it, but you need to think about it before the... yeah, you can do it even as a foliar application. There are lots of foliar application of boron. If you have excess, it damages top leaves. Basically, it's like fungicide, pesticides, herbicide. They use it sometimes as a herbicide because high concentration, they can kill a plant. And it's very easy. It's a good herbicide because it kills plants, and first rain comes and just flush into the soil and it's gone. So you don't have consequences. Sources. I don't have a sources. Boron you can replace with borax. This is the most available element you can find in a grocery store. It's used for laundry. Yeah, so borax is a good source, or some Britain salt. I'm not sure what's the name. Borax is probably the best. I think it contains 11% of boron, so you can replenish it. Okay. Iron also. Deficiency of irons, how they looks like. Manganese. I can keep it, this presentation for you. You can read it. Goes through. Zinc, molybdenum, cobalt, and or you know, it would be good if you sign up. How we'll do it? Is there? Yeah. Yes, we can do it. Yeah, we have a WhatsApp group, for example, European Agriculture Conference WhatsApp group. So those who are not signed up, just ask us, and I can post it over there. Okay, or just send me email, give me email. I can do it. So when you do soil analysis, it has to contain this CEC value, which is cation exchange capacity. There are several methods how it is done. It's based on acidity of the soil or pH of the soil. What I use, it's a Melick tree method, but I find out there are some, even in Slovakia, lots of calcareous soil, calcic soil. I use AA 8.2 ammonium acetate extract. So yeah, maybe these are too complicated, but the overall is you will get information about all elements that, not all, but elements that you are paying for. And you also get information about something like what's the capacity of your soil. So 17 is fine, perfect. It doesn't matter what kind of capacity you have. Even smaller capacity is good for you because you can very easily get the balance. Of course, you need to do much more often. But when you have a very high capacity of soil, heavy soil, they have capacity 25, maybe 30, sometimes 50, and it's hard to get balance because you need to add lots of amendments in order to get balance, or lots of organic matter that can create biology that can access other minerals that are missing, that are not available. You get information about pH, you get information about organic matter in that soil. And for example, I see sulfur ppm 16, very low. I have a table that I recalculated from those 16 ppm. I know that I need, this is a target value, 278 kilograms per hectare, and I miss 243. So heavy application of sulfur that year. And how can I replenish this value? I use elemental sulfur, which contains 98% of sulfur, which means I need, for my 240 square meters, I need 11 kilograms of sulfur for application into 30 centimeters of, or 15? 30 centimeters of depth of soil. It's a plow depth. Usually I do it for 15 centimeters. It depends what are your agriculture techniques is. Okay, so I will finish with a conclusion. I will finish that optimal mineralization is the base. It's an important step. how to create this loop, how to create a functional loop of flourishing plants. But it's not enough, it's not sufficient. Once you have those ideal conditions, you need to take care of other things. You need to support biology in the soil in order to keep it that way. You need to do everything so that the photosynthesis has the right condition, so it feeds biology, biology feeds minerals, and minerals goes to the plant. So it needs to be, this is what I'm showing you, this is just intervention, but it's not the primary goal. Primary goal is to have a garden that was designed by God, and it works by itself, by God's grace. You need to add organic matter sometimes because it's lacking some holding, it lacks holding some important essential minerals and so on. So let me finish with this quote, also from Book of Education. One day, it's talk about young people learn what science can teach in regard to the nature and preparation of the soil, the value of different crops and the best methods of production. Let those kids, young people, put their knowledge into the use. And I'm so happy that we are here in Integritas and we can see that young people are involved in whatever is going on within this facility. They are involved in the practical thing. They can not only study, but they can also use it and see that really this is something that works. Okay, so thank you for your attention, and really, I will stay a few words in prayer, and if you have a question, just stop me by. Okay, please stand up. Dear Heavenly Father, I would like to thank you for your blessing, for your mercy, for the time that we could spend, even we are almost hungry, we would like to eat. We would like to ask you for giving us strength and wisdom to use information in a proper way, so we can be good manager of the soil, something that you gave us to take care of. Please also bless us the food we will take in a short moments, and please bless also the other activities of this day and prepare us for your holy Sabbath. Amen.